Hi everyone, this is your last section for this course. And there's two lectures I'm going to cover both on bonds. Okay, so I'm going to give you a lot of information or background information on bonds within these next 4 slides. I encourage you to look through them or kind of keep them with you as you start doing problems. There's a lot of terms in here that do take some time to get used to. Okay, so starting with the basics, a lot of governments and corporations, they use bonds to borrow money. Okay, so they borrow money from you, and the bond is the actual written contract between the lender and the borrower. Okay, so whoever's borrowing it, usually it's a government trying to raise funds, and you're lending money to them. So within that bond, they have several terms in that contract. Okay, and they break down the different aspects of it that are going to be satisfied. The first item is known as the face value. Okay, so that's the amount that's owed to the bondholder. In this case, if you purchased a bond, it'd be owed to you at maturity. The bond rate is the rate of interest paid. Okay, so that is stated on the bond that it'll earn something like 5% interest, and it's payable semi-annually. So it's not compounded semi-annually, it's payable semi-annually. You'll see why that's important when we talk about coupons. Okay, so you can see the other term for it is known as the coupon rate, and we'll get into that in a later slide. The next item is the maturity date. So that's when the principal of the bond has to be repaid back to the bondholder. In this case, you can consider it being you. And lastly, the principal is the amount that they actually pay you. Okay, so there's two items here that are very similar. You'll see face value and principal. Okay, so that's the face value is the amount that's owed to you, but the principal is actually the amount paid. So you can have bonds where they pay you more than that face value or slightly more than what you paid them. The face value is typically what you paid them. And there's reasons for that. There may be additional clauses in the contract. So these are the 4 major items you need to keep in mind. It basically describes the terms of the loan. The face value, okay, so how much you provided to them or lent to them, let's say it's $10,000. The bond rate, the rate of interest, and remember it's paid, so it's not compounded semi-annually. It means that you will earn interest if it's semi-annually twice a year. And the last two, the maturity date and principal. Maturity date's when the bond comes due. In other words, when it has to be paid back to you. And the principal is how much you were actually paid back. So I repeated the 4 of them just to give you some examples. But remember, this is a very important set of terms that you're going to need to know when we start going into some questions. So a little bit more on bonds. Okay, most of them are redeemable at par. And what that means is if you go back to my 4 terms, I had face value and principal. Okay, the face value was actually the amount that you paid to them. Let's say it's $10,000 for the bond. The principal is how much they actually pay back to you. So if it's redeemable at par, which most are, then at the end of the bond period, they'd pay you back $10,000. And during the period, you would be earning interest, okay? And that interest would be paid to you at that time. But there are instances where these two items are not the same. So you might have purchased the bond for $10,000 and they might have, let's say, paid you $11,000. So you might ask, why is that the case? Okay. Well, there's two kind of major features you can consider. One's called a puttable and one's called a callable bond. Okay. So in a puttable bond, that means that let's say you need the money back early, you can actually return the bond and be repaid before the maturity date. So let's say if you purchased a bond for $10,000 and it was 5 years long, if you needed that money in 4 years, you could technically return the bond and be repaid in 4 years. The second item is known as a callable bond. So callable bond meaning the government or the company can call that bond or ask you to return it and they can pay you. And if they do that, usually they pay you early. So they normally will pay you more, right? They will pay you a premium for it or more than what you paid in order to get that bond back early. Okay, and there's a variety of reasons as to why governments or companies may do that. So that's an example where those two terms, face value and principal, would not be the same. So another thing to consider, and I've been talking about this, buying and selling bonds. So they're what's called marketable, meaning they can be freely bought and sold. You can purchase a bond and you can sell it to someone else, or you can purchase someone else's bond. And when you do that, there's several factors that have to come into play when you're buying and selling. We're going to get into that in the next section. But in general, when you purchase a bond, you're technically buying. I know you can't see me because it's on video, but doing kind of parentheses, my fingers, buying two promises. The first is that you're going to be paid the principal of the bond at maturity. In other words, the amount you paid for it plus any premium there may be. And two, you're paid the periodic interest rates. So remember, I said usually the interest is paid semi-annually, okay? And that interest is based on the bond rate, okay? So if you had a $1,000 bond, or let's make it an easier example. If you had a $100 bond and your interest was 5%, what that means is every year you would be paid $5 in interest, okay? Those are usually called coupons, okay? So if you're paid it semi-annually, that would mean 6 months through the year, you'd be paid $2.50. And then 6 months later, at the end of the year, you'd be paid the remaining $2.50 for a total of the $5 you would have been owed for that year. The reason they were called coupons was before everything, a lot of our kind of day-to-day transactions being electronic, they were actual coupons that were attached to the bond that you would take off and bring to the bank to be paid that interest. Okay, so that's the reason that they're called coupons. All right, and you'll actually earn that specified interest amount. Okay. So the last item I'm going to talk about, this is a lot of information. So I do encourage you to either listen to this video and watch it more than once, or to have these pages with you as you're going through questions so you can cross-reference each of these terms. So there's 3 scenarios we're going to talk about when you purchase a bond. And each of them depends on the market rate of interest compared to your bond rate. Okay, so the bond rate, remember, is the rate of interest stated on the bond. The example I've been using is 5%. The market rate is what you can reasonably expect putting your money just in the market, say in the stock market or in investing it in some way and earning a standard rate of return. Okay, so if the market rate is also 5%, then your bond is sold at its face value. So again, we use an example of a $1,000 or $100 bond, I should say. So that means if the market rate and the bond rate are the same, then your bond would be sold. If you went to sell that bond, you would sell it for $100 plus any interest that's been accrued on it, okay? In each of these examples, you'll see that you have to take into account interest earned. Because a lot of times you'll buy a bond and it'll start as of that date and it'll continually be earning interest. So you want to earn that addition, you want to sell it while also making the money on the interest that you would have had while it was accruing and while you owned it. The next item is if the market rate is higher than the bond rate. So let's say if you were to invest your money in the market, you'd make 6%, but your bond is only paying 5%. Okay, so what that means is that your bond will be sold at a discount, okay, below the face value. In other words, in our case here, it might be sold at something like $90. And the reason for that is that person's not going to go and buy the bond with that $100 when they could take that, put it in their market, into the market and make more money. Okay, so usually you have to sell it for a little bit less to entice somebody to purchase it. Similarly, okay, again, that's plus interest. And similarly, if the market rate's less than the bond rate, let's say it's 4% and the bond rate is 5%, then that bond sold at a premium because the bond that you own, okay, is actually earning more money than if someone invested in the market. So in this case, maybe it'd sell for $110 plus interest. And we'll go into the specifics of these calculations later on in this lecture. Okay, but in all these cases, that just explains kind of how the purchase price changes. And the overall price is known as the cash price. So the cash price is equal to the market price. So that could be the face value of it, or it could be at a discount, or it could be at a premium, depending on, again, what the market rates are, plus any interest that's been earned to date. Okay, so you remember we've been doing interest calculations kind of all throughout this course, so I'm going to walk you through an example of this just to show you it before we get into some more specifics. So, our first example, a $10,000 5-year bond redeemable at par and bearing interest at 6.5% per annum, payable semi-annually, is purchased at a market price of $10,000 4 years and 10 months before maturity. Determine the cash price of the bond. So like I said, the cash price is equal to the market price plus any interest you've earned. Okay? And one thing to note about interest is it's based on the face value of the bond. Interest is never calculated based on what the market's seeing, right? The market price will fluctuate based on interest rates in the market. But your interest calculation when you purchase a bond is always based on the face value, in this case $10,000, and the interest rate or the bond rate associated with your bond. Okay? So 6.5% is the bond rate and $10,000 is the face value. In this case, it says it's redeemable at par. So it makes sense that the market price is the same, $10,000, right? Going back to our previous slide where if the market rate and the bond rate were the same, then it's redeemable at par. Okay? So what this means is our market price was given in the question is $10,000. And our interest has to be calculated for the period of time that we've owned the bond, okay, before you're selling it, okay, at that period in time. So the bond is actually 5 years, but we're looking 4 years and 10 months before maturity, okay? So in other words, subtracting 4 years and 10 months, that leaves us with just 2 months that we've been accruing interest on this, right? So we look at our timeline, we're at time 0. The bond comes due at the end of year 5. So 1, 2, 3, 4, year 1, year 2, year 3, year 4. And we're going 4 years and 10 months before maturity. So 1 year, 2 year, 3 years, 4 years, and then 10 months. We're taking it to this period in time, which is 2 months after we purchased it. So we're only earning interest for 2 months. So what that means is our cash price has to be equal to our market price, $10,000, plus the interest we've earned on it. And remember, we know the annual rate of interest, which is 6.5%. Okay? So if the interest is equal to 6.5%, it's the same as 0.065 if you convert it to a decimal. So our interest is equal to 0.065 But remember, we have to do it as a fraction of the year because we only earn interest for 2 months out of the year. So in other words, 2 months divided by the total number of months in the year, which is 12. Remember, think back to our previous lesson when we did this, looking at the number of days in a year when we were calculating interest on a mortgage. So 2 months divided by the 12 months in a year. And again, remember, interest is calculated on the face value. In this case, the face value is the same as the market price, or $10,000. And if we calculate this out, we get $10,000 plus $108.33. So what that is for the 2 months that this bond has been available, or you've owned the bond, you've earned $108.33 in interest, okay? So if you were to try and sell the bond right now, you would sell it for $10,000 plus that interest that you've earned. In other words, $10,108.33. Because remember, that bond is worth a little more now because you've earned interest. Again, you haven't earned it over the entirety of the bond period, the 5 years. So that's why you do just a partial interest calculation. Okay? So the next types of purchasing that I want to talk about, there's 2 types. The first one is if you purchase a bond on an interest payment date. Okay, so payments are usually annual or semi-annual for interest. So there's really only 1 or 2 days a year that this could happen. But we're going to talk about this one first. And in each of these examples, unlike the last example we just did, you'll notice that the market interest rate will be higher or lower than the bond rate. So it'll either be selling at a premium or at a discount. So for a bond, there's 2 types of cash flows, okay? The value of the bond at maturity, that's what we know as the face value, and the interest payments you're earning during the term of the bond. So if you're trying to purchase a bond today, then you need to find the present value of both the face value, which is the value you're going to get at maturity, 2, 3, 4 years down the road, plus the present value of all those interest payments every 6 months or every year, depending on when interest is payable in your bond. Okay, so it goes back to finding the present value for both those. What you'll notice is for the face value, it's just a number, say $1,000, 3, 4 years down the road. So that can just simply, you can find the present value using compound interest. But for interest payments, it's regular, equal payments, semi-annually or annually. So that is an annuity. So combining those two, it means that the purchase value is equal to your face value, okay, FV, so similar to future value because it is in the future, divided by 1 plus the periodic interest rate to the exponent of n. That's just a basic compound interest formula, plus the payment, okay, times this formula in brackets, which in other words is the present value of an ordinary simple annuity. So our first sets of examples are going to show you that the payment frequency for your interest payments and the interest compounding frequency, so taking your market value and looking at how often it's compounded, they're the same. So if they're the same, it's the exact same as an ordinary simple annuity. So that's the option that we're going to look at first before then looking at ordinary general annuities. So in terms of the items you have to figure out in this problem, FV is your face value. Okay, so that's the amount of the bond at maturity. I is your periodic interest rate. And the key word here is you use the market rate, not the bond rate. The rate in the bond, the percentage that's given in the bond, that is only for calculating your interest payments. Okay, how much interest you're earning on that bond. Okay, when we talk about periodic interest rate, remember, going back to our timeline, money is worth something at every period in time. So when we're going from the maturity date, and then periodically we have these interest payments, when we're discounting that back to today, we're using the market interest rate, right? Because we're trying to figure out the value of those payments today. So we have to use the market interest rate. That's very, very, very important, okay? Not the bond rate. Where the bond rate is used is when we try and calculate our payments. Because in this case, our payments in the annuity are just our regular interest payments that we would receive from owning this bond, okay? So how to calculate that is you take your bond rate, whatever that rate of interest is, divided by the number of, this should say, payment periods, not compounding periods, so payment periods. In other words, how often you're being paid these interest payments. And you multiply that by your face value of your bond, okay? Because that's how your interest is calculated, okay? If you have 6% interest on a bond and it's semi-annual, okay, interest payments, and the bond is worth $100, what that means is that if it's semi-annual, you get 2 interest payments a year. And each one of them will be 6%, okay, your interest rate divided by 2, right, because there's 2 payments, multiplied by your face value, okay? So what that means is in this case, twice a year, you would get a payment of $3. And that would happen every single year until the bond is mature, okay? So those are some key distinctions. I think once we do a couple of examples on these, they will start to make a little bit more sense to you. So our first example, a $1,000 bond bearing interest at 6% per annum, payable semi-annually, is due in 4 years. If money is worth 7% per annum compounded semi-annually, what is the value of the bond if purchased today? First thing you notice, okay, semi-annual and semi-annual, okay, so that means since the payment period frequency and the interest compounding frequency are the same, it's an ordinary simple annuity. Another thing you're going to start seeing, okay, the bond rate is 6%, but our market rate is 7%. So if our market is earning a higher interest, that means that this bond should sell at a discount, or the number we obtain at the end should be less than $1,000, right? Because it's not going to earn as much money as if you had just invested it in the market, okay? So we start with the formula that I showed you, okay? Purchase price is equal to, the first is the face value divided by 1 plus the periodic interest rate to the exponent n. That's using the face value of $1,000, plus you're finding the present value of all of your interest payments. So your payment multiplied by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n divided by the periodic interest rate. Okay? So these are just basically the two formulas you write down in each of these scenarios. And now we just need to find each of these variables. So we know our face value of the bond. Okay, it's $1,000. It's provided in the question. We also know that our interest rate, okay, in this case our market rate is 7%, which is equal to 0.07. And it is compounded semi-annually, so the value of m is 2. So our periodic interest rate, I, is j divided by m, or 0.07 divided by 2, which gives us 0.035. The next items we need to calculate are going to be slightly different than when we did typical annuities. Okay? The first item is your value of n. Okay? So n in this case is how many payment periods we're going through. Okay? So what that is the bond is for 4 years, and you get 2 interest payments per year. So your total number of periods is 4 times 2, which gives you a value of 8. Okay? The next item that you need, okay, is your payment. That's your last item. So these last two pieces are done a little bit differently than we've done with annuities. So your payment, remember, In this case, it's semi-annual, so every 6 months, we're going to get an interest payment. And it's based off the face value. So it's based off of your face value of your bond, $1,000, multiplied by your interest rate, okay? But it has to be divided by the number of payment periods, because again, consider this like a periodic interest rate for your bonds. So your bond interest rate is 6%, which is 0.06, and you're getting payments twice, okay? So you divide that by 2, because you're not going to get the full 6% each payment, you're going to get half of it, right? Half in 6 months and half in the other 6 months. So if you calculate that out, that means every 6 months, you're going to get a payment of $30, okay? So with all this information, we're going to substitute it in, and you're going to see that you're going to get a price, in this case, because the market rate of interest is higher than the rate in the bond, your purchase price should be less. You should be purchasing this at a discounted rate. So substituting these in, your face value is $1,000 divided by 1 plus the periodic interest rate, 0.035 to the exponent 8, plus your payment, $30, multiplied by 1 minus 1 divided by 1 plus the periodic interest rate, 0.035 to the exponent 8, divided by the periodic interest rate, 0.035. And if you multiply each one of these out, you get $759.41 plus $206.22. So what you end up with for a total is $965.63. And you'll see that that's less than the face value of the bond, okay? What that means is this bond is selling at a discount, okay? Because it's worth less than the face value, okay? Let's look at one more example. A $5,000 bond bearing interest at 6.5% per annum payable semi-annually matures in 10 years. If the market rate is 5.8% compounded semi-annually, what is the purchase price of the bond? Okay, a couple items to notice. Your interest on your bond is payable semi-annually, and your market rate is compounded semi-annually. So this would be considered an ordinary simple annuity, since those two are the same. The next item to notice is that your bond has a 6.5% interest, and your market rate is only 5.8. So in other words, since your bond's interest rate is higher, you can expect the number we get to be greater than the face value of $5,000. In other words, selling at a premium. Okay? So just like in the last question, we're going to start with our formula. The purchase price is equal to our face value divided by 1 plus the periodic interest rate to the exponent n, plus the annuity portion, so our regular interest payments, multiplied by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n, don't need this bracket here, divided by the periodic interest rate. Okay? So again, I start writing all of the items that I have. In this case, my face value is $5,000. Our nominal interest rate is 5.8%, which is equal to 0.058. Our number of interest compounding periods, M, is semi-annual, so it's 2. So our periodic rate of interest, I, is J divided by M, or 0.058 divided by 2, which gives us 0.029. Our last item we can calculate here is N. This is the number of payment periods. Okay, so the bond is 10 years, and your payments are semi-annually. So 10 times 2 means you'd have 20 interest payments total. Next, we need to calculate our payment. Okay, and remember, it's based off the face value, 5,000, multiplied by our bond interest rate, 6.5%, which you can convert to 0.065, divided by the number of interest payment periods per year. In this case, semi-annual is 2. So if you calculate that out, you get a payment of $162.50. So now again, just like the previous example, we can substitute these values in. And keep in mind, we should be getting a premium, right? It's an easy item to see when you see the two interest rates, okay? So you know if you did something wrong in the calculation if you're not obtaining, in this case, a number greater than 5,000. So our purchase price is equal to our face value, 5,000, divided by 1 plus the periodic interest rate, 0.029, to the exponent 20, plus our payment, $162.50, multiplied by 1 minus 1 divided by 1 plus the periodic interest rate, 0.029, to the exponent 20, divided by the periodic interest rate, 0.029. And if you calculate each one of these out, the first number would come out to $2,822.69, plus the value of our payments, $2,440.09. And if you add those two together, you get a purchase price of $5,262.78. So again, you notice that that's greater than $5,000. So it's selling at a premium. And again, that's because you're going to make more money, all things being equal, with the bond in that same $5,000 than if you placed it just in the market. So the next item I want to discuss is the exact same style of problem, purchasing a bond on an interest payment date. But if the interest payment frequency is not the same as the payment frequency for interest, then it's an ordinary general annuity. Okay, so the only difference, again, is that you have to calculate the equivalent rate of interest, P. And it's the same formula that we've been seeing throughout this entire course. 1 plus the periodic interest rate to the exponent C minus 1. And C is again equal to the number of interest payment periods divided by, or compounding periods, divided by the number of interest payment periods. Okay, so it's the exact same version of the formula. Okay, so again, that's the only item that's changed. So we'll do 2 examples looking at bonds as ordinary general annuities. Okay, so a municipality issued $1,000 bonds with interest at 3% per annum payable annually, which mature in 10 years. If the market rate is 4% per annum compounded quarterly, what is the purchase price of the bond? Okay, so you notice interest is compounded quarterly on the market rate, but for the bond, it's payable annually. So that makes it an ordinary general annuity. The other thing you're going to notice is the bond is only 3% interest, while the market rate is 4%. So we can expect this to be a discount. Okay? In other words, the value should come out less than $1,000. Okay? The reason I'm telling you to look at that each time is so that you know whether you're moving in the right direction as you make this calculation. So I'm going to start with our formula. Purchase price is equal to the face value divided by 1 plus the equivalent rate of interest, P, to the exponent n, plus our interest payment multiplied by 1 minus 1 divided by 1 plus the equivalent rate of interest, P, to the exponent n, divided by the equivalent rate of interest, P. So exact same calculations with a few additions. All right? So our face value in this case is $1,000. Our nominal rate of interest, J, is 4%, which is 0.04. And in this case, our interest compounding periods is quarterly, so M is 4. So our periodic rate of interest, I, is J divided by M, or 0.04 divided by 4, which gives us 0.01. The next item we can calculate here is our ratio C. That's the number of interest, compounding periods, divided by the number of interest payment periods in this case. So interest is compounded quarterly and payments are annually. So it's 4 divided by 1, which gives you a value of 4. So we can calculate our equivalent rate of interest P, which is 1 plus the periodic rate of interest I to the exponent C minus 1. In this case, P is 1 plus the periodic rate of interest, 0.01, to the exponent 4 minus 1. And if you calculate that out, you get 0.0406. Okay? The next item we can calculate is N, so the total number of payment periods. In this case, it matures in 10 years, and you only get one interest payment per year. So 10 times 1 gives you a value of 10. Similarly, for payments, we start with the face value, and we multiply it by the bond interest rate divided by the number of payments per year. In this case, 3%, which converts to 0.03, and it's divided by 1 because we only get one payment a year. So in this case, our payments are $30 per year. So if we substitute all of these values in, our purchase price is equal to our face value, $1,000, divided by 1 plus the equivalent rate of interest, 0.0406, to the exponent 10, plus our payment, $30, times 1 minus 1 divided by 1 plus the equivalent rate of interest, 0.0406, to the exponent 10, divided by the equivalent rate of interest, 0.0406. Okay? You calculate each of these numbers out, we get a value of $671.68 plus $242.60. So adding those two up, you get a value of $914.28, which again is less than the face value of $1,000. So this is purchased at a discount. Okay, that again is a good check to make sure that you did these calculations correctly. So one more example for another ordinary general annuity. A $7,500 bond was issued with interest at 6% per annum payable semi-annually and matures in 6 years. If interest is 7% per annum compounded annually, what is the purchase price of the bond today? So again, we look, payments are semi-annual, but interest is compounded annually, so it makes it an ordinary general annuity. Interest on the bond is 6%, while the market rate is higher at 7%. So it means we should see this being purchased at a discount, okay? Because the interest in the bond is less than the market rate. So we start with our formula. Purchase price is equal to the face value divided by 1 plus the equivalent rate of interest to the exponent n, plus our interest payments times 1 minus 1 divided by 1 plus the equivalent rate of interest p to the exponent n, divided by the equivalent rate of interest p. So compiling all of our numbers, our face value in this case is $7,500. Our nominal rate of interest J is 7%, which equals 0.07. Our number of interest compounding periods in this case is just 1. So our periodic interest rate I is J divided by M, or 0.07 divided by 1, which gives us 0.07. Our ratio C is the number of interest compounding periods divided by the number of interest payment periods. In this case, interest is compounded annually and payments are semi-annually. So it's 1 divided by 2, which gives you 0.5. So our equivalent rate of interest, P, now can be calculated. It's 1 plus the periodic rate of interest, I, to the exponent C minus 1. In this case, 1 plus 0.07 to the exponent 0.5 minus 1. And if you calculate that out, you get 0.0406. 3441. The next two items we can calculate first is our total number of interest payment periods, N. This matures in 6 years, and interest payments are semi-annual. So 6 times 2 gives us a value of 12. For payments, again, we start with our face value, $7,500, and we multiply it by our bond rate of interest, 6%, which is 0.06, divided by the number of interest payments per year. In this case, it's semi-annual, so you divide it by 2. And if you do that, your payments come out to $225. So $225 twice a year. Substituting all of these values in, we get a purchase price equal to our face value, $7,500, divided by 1 plus the equivalent rate of interest, 0.03441, to the exponent 12, plus our payments, $225, times 1 minus 1 divided by 1 plus the equivalent rate of interest, P, 0.03441, the exponent 12, divided by the equivalent rate of interest, 0.03441. And if you calculate each of these out, you get $4,997.45 plus $2,181.82. So if you add those up, that's equal to $7,179.27, which again is less than the face value of $7,500. So it's once again purchased at a discount. Okay? So the last item I want to talk about is if you purchased a bond between your interest payments. So the last two sets of examples looked at if you purchased a bond directly on a day that you would have been provided with an interest payment. Okay? But like I said, they're usually annual or semi-annual. Okay? So that means there's usually only one day that happens if it's annual, or 2 days if it's semi-annual. So more often than not, they're purchased in between interest payments. Okay? So the method, you're still going to use the same formula, but you have to do a couple additional steps. So what you do is you actually have to start at the maturity date. Okay? So if you picture, you start at the maturity date, and you have to work backwards. Okay? So if it's semi-annual, you take that date and you figure out every 6 months I have a payment until you reach a point where you have a payment here. Okay? And that payment is directly before when you're trying to purchase the bond. Remember, you're purchasing it in between payments. So picture this being January 1st. Okay? And you want to purchase somewhere like February 10th. Okay? So if it's, you go backwards to the point that's the interest payment that's directly behind it or before it, and you use the exact same formula. Okay? In this case, N is the number of payment periods you're going back. So in this case, 1, 2, 3, 4, 5. Then with that number, what you're calculating is the purchase price at this point in time. Okay, January 1st. That's before when you actually wanted to purchase it. So what you have to do is once you obtain that value, you then have to go back forward using compound interest to figure out what the value is at that later date after it's accrued some interest. Okay, so most of this is actually going to be the same styles of formulas. Okay, with this one tweak of working backwards. So I'm going to do just one example of this. Okay, a savings bond with a face value of $1,000 bearing interest at 6% per annum payable semi-annually matures on August 1st, 2018. What is the purchase price of the bond on April 17th, 2016 if the market rate is 5.4% per annum compounded semi-annually? Okay, a couple items to notice here. They're both semi-annual, so it means it's an ordinary simple annuity. Okay. Also, your market rate's 5.4%, but your bond rate is 6%, which means it should be selling at a premium. Okay. So again, we're going to work backwards. So we're starting at the maturity date, August 1st, 2018. And you're trying to purchase on April 17th, 2016. So we need to find the interest payment that happened directly before that. So in this instance, interest is payable semi-annually, so every 6 months. So I'm going to just count 6 months back, because we know on the last day, the day of maturity, you're going to earn a piece of interest. It's the way bonds work. So 6 months before, you go July, June, May, April, March, February. That's 6 months. So that means it's going to be February 1st, 2018. Okay. Then 6 months will put us at August 1st, 2017. Then February 1st, 2017. Then August 1st, 2016. And we're still not at our date. So if we go back one more, February 1st, 2016. Well, our date is somewhere in the middle here, April 17th, 2016. So we went back one further behind, okay? Just like I said in the previous slide. So what that means is we went 1, 2, 3, 4, 5 payments, okay, in the past. So that means our value for n, in this case, is 5, right? So we're going to translate this back to February 1st, 2016, then use compound interest to find the interest that was accrued on that to get it to April 17th, 2016. Okay? So again, now that we figured that out, we just start with our formula. Our purchase price is equal to our face value divided by 1 plus the periodic interest rate to the exponent n, plus our interest payments times 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n divided by the periodic interest rate. In this case, our face value is $1,000. Our interest rate, J, is 5.4%, which is equal to 0.054. Interest is compounded semi-annually, so M is 2. So our periodic rate of interest, I, is J divided by M, or 0.054 divided by 2, which gives us 0.027. Our next items that we know n is 5, right? Because we're moving 5 payment periods into the past. And the last item we need is our payment. Okay? Let's calculate it the same way. Our face value is $1,000, and it's multiplied by our bond rate, which is 6%, or 0.06, divided by, in this case, 2, because interest is payable semi-annually. So if we calculate that out, our payment comes out to $30. So substituting those values in, our purchase price is equal to our face value, 1,000, divided by 1 plus our periodic interest rate, 0.027, to the exponent 5, plus our payment, 30, times 1 minus 1 divided by 1 plus our periodic interest rate, 0.027, to the exponent 5, divided by 0.027, our periodic interest rate. So, you calculate those two numbers out, you get $875.28 plus $138.58, which comes out to $1,013.86. That is the value right here. Okay, I'll do it in a different color. Before you're trying to purchase it. That's as of February 1st, 2016. So now we have to use compound interest to find the future value of that on the day we want to actually purchase it. Okay, which is April 17th, 2016. So to do that, we use our future value formula. I'll do it in a different color. Future value is equal to the present value times 1 plus the periodic interest rate to the exponent n. So a couple items we know that are easy. The present value is $1,013.86. Our periodic interest rate is 0.027. But the last item is what is n, right? We're not moving a full period into the future. So what we have to do is we have to figure out how much of one period are we going, okay? One period is 6 months. 6 months is half a year. So one period is 182 days approximately, or 183. I would let you use either number. And how far we're going is how many days we're actually going into the future. So we're going all of February. February has 28 days, plus all of March, which is 31 days, plus 17 days in April, because we're going to April 17th. Okay? So what that comes out to is 76 out of a possible 182 days in that period. And that comes out to 0.41758, or just under half a period. So we can substitute those numbers in. Our future value is equal to our present value, $1,013.86, times 1 plus our periodic interest rate, 0.027, to the exponent, 0.41758. Okay, so a partial period. And if we calculate that out, we get a future value of $1,025.20. The only kind of trick here was calculating this value of n. So what you'll see in these questions is that it will not be a full period, because you're always going just to the period before and then doing a partial calculation to move it forward. Okay, so you will notice in that case that n will be a decimal place. All right. So that was all I had for this lesson on bonds. We're going to have one more lesson to post that will consolidate the last two items associated with bonds. Okay, so I will post that as the next lesson. In the meantime, if you do have questions, please send me an email. Thanks.